Hello and Assalamualaikum. My name is Muhammad Akmal Hakim bin Muhammad Hadi. For the introduction of our group, the semi-active suspension is one of the suspensions that elastic parameter stiffness and the shock absorber damping can adjust according to the need for adjustment and control. The spring stiffness tuning is very difficult, so semi-active suspension mainly by adjusting the shock absorber damping. Semi-active suspension has no specifically dynamic control component, a twin tube viscous damper in which the damping coefficient can be changed by the altering the diameter of the aperture of a piston. Hello and Assalamualaikum. My name is Muhammad Akmal Hakim bin Muhammad Hadi. My metric number is B09201017. For the summary of the lecture as FI review, the title of the lecture is A New Semi-Active Suspension System for Vehicle Application. The name of the paper is Dynamic System and Control, or DSC. The month of or year of publish is October 2017. The methodology is experimental, is compared between a quarter car vehicle model with single and double damper suspension. The simulation tool is been using in this experiment with a flowchart of input and output for vehicle. For the result, that demonstrates that the novel semi-active suspension system can emulate as active suspension without bottoming the suspension or deterioration of the road holding properties. The system performs like a fully active suspension system, and it reduces the power consumption, reduces the complexity, and reduces the cost. For the methodology, first, the analysis of double damper semi-active suspension design. For semi-active control of double damper, first, the control force are computed assuming a full active system, and then by imposing the constraint. The system is used in a semi-active mode. The second one is the application of dynamic tire model in development of suspension control. This vehicle model with dynamic tire model is used for evaluating the right performance of no control, fully active control of single damper suspension, and semi-active control of double damper suspension. A linear-based reactive rate control algorithm using a quarter car vehicle model with single damper and double damper suspension is developed. In ideal skyhook, ground hook, 2 degree of freedom suspension is used as the reference model. The tire model and active suspension control are then integrated with the full vehicle mode to perform ride analysis. Using RMS acceleration or sprung mass vertical, roll, and pitch motion as a ride performance metric, ride performance of no control, fully active control of single damper suspension, and semi-active control of double damper suspension are performed. The simulation tool. The force at the axle act as input to the vehicle model to compute deflection of axle and vehicle chassis. Using this deflection and force at the axle input to suspension control module is compute optimal damping semi-active or control force fully active based on skyhook ground reference model. And for the result, the advantage is clearly increase in number of control damper is during joints or rebound. The respective damper associated with sprung mass resort to minimum damping with affecting road holding capability of unsprung mass and paralleling the unsprung mass resort to minimum damping without affecting the vibration insulation of the sprung mass. From the article, it is observed that the dynamic response of the tire is a deform around the road profile, characterized both of the longitudinal and the vertical dynamic of the tire and suspension. The ride performance was evaluated under short wavelength road profile and road profile wicklage. The simulation result demonstrate that the novel semi-active suspension system can emulate as active suspension without determining the suspension or deterioration of the road holding properties. The semi-active suspension results are shown to be constrained in saturation and energy limitation of the damper. This approach of ride control shows that the double damper can be substituted full active suspension and show the significantly improve the ride performance of the vehicle at the reduced power consumption, cost, and complexity with more reliability.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akmal bin Bakar and I'm going to present my study on the paper. So the title is a study on a vehicle semi-active suspension control system based on road elevation and identification. So the next paper is from PLOS ONE. It is published at June 2022. So the methodology is pavement elevation recognition. The second, semi-active controller design, and third, overall the system design. So the result is the suspension vertical acceleration and also the seat acceleration. So for the discussion on my study on this paper, for the methodology, it has 3 components. That is pavement elevation recognition, semi-active control design, and also overall system design. So the pavement elevation recognition, it uses LiDAR continuous scanning recursive matching algorithm to compute accurate road roughness information based on low cost single line radar and the toughness grade of the pavement is obtained. When the vehicle is driven, the single line LiDAR emits laser beams to detect and scan the pavement elevation. Continuous scanning recursive meshing algorithm is proposed to improve the accuracy of the contour elevation of the obstacle in front of the vehicle by performing multiple continuous scanning recursive matching on the laser pulse echo signal. So the second is you need to design the semi-active controller design. An intelligent control algorithm named Diagonal Recurrent Neural Network (DRNN) is designed to suitably include in a semi-active suspension system. The controller receives input such as vertical acceleration, suspension dynamic stroke, and the tire dynamic stroke related to the vehicle ride comfort and response handling stability. So the last step is they need to do the overall system design. So the first is the RNN controller design in section 3 has self-organization and self-learning function. It can satisfy perform fault tolerance, nonlinear approximation, and adaptive control. However, the feedback control of the hydraulic actuator is effective only after the suspension is excited and the state changes. Therefore, to achieve a more effective control effect, a pre-RNN fusion algorithm was developed, and the road information obtained in advance was taken as feed-forward term and combined with the semi-active suspension feedback control. So for the result, from this study, they had two results, that is suspension vertical acceleration and also the seat acceleration. So the root mean square value of the vertical acceleration of the suspension system reached 3.2416 meter per second in 0.4 second when the RNN control algorithm was adopted for the semi-active suspension control. Once the road elevation preview algorithm was integrated into the system, the root mean square value of the vertical acceleration was 2.7312 meter per second. With the pre-directed strategy control, the damping performance of the semi-active suspension is improved by 15.75%. So, the second result is the seat acceleration. When intermittent bumpy road acceleration is applied, the road mean square value of the seat acceleration resulting from the pre-direct algorithm is lower than that of the direct algorithm. This indicates that the control method can improve the ride of the vehicle. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzat bin Ahmad Rashidi. My matric number is B0920101010. Today I will be reviewing a study journal. The title of the journal is Semi-Active Suspension System from Research to Mass Market. So basically this journal writes about the semi-active dampers principle, the control of the semi-active suspension from classical to modern, and also reviewing about the results. So we'll go through the semi-active dampers principle. Basically, the dampers principle contain three principles, which is servo and solenoid, magnetohydrological and electrohydrological, and also electromagnetic dampers. So for servo solenoid valve dampers consisting of valve that control the flow of hydraulic oil by passing the orifice tube at the damper piston. So second, the magnetohydrological MR and the electrohydrological ER dampers use special non-Newtonian fluid that contain micron-sized ion that respond to magnetic field, and the flow through the orifice tube controlled by an electromagnetic device. Lastly, the electromagnetic dampers did not use any oil in the damper, but fully use the electromagnetic principle between a coil and a permanent magnet. The damping force is controlled by resistor. We move on to the control strategies. We go to for the classical control strategies. For classical control strategies, it let the user to select and use preferred damping control such as skyhook control that adjusts the compression and rebound force, while ground hook control tends to increase the damping and reduce the deflection. Uh, the second control strategies is more modern control strategies. The modern control strategies uses more advanced control device with more complex algorithm developed using computer software and analyzing quarter car model to control the damper deflection speed and widen the damper force to switch the road surface and driving condition. Modern control strategies such as optimal control, model predictive control, and fuzzy logic control. So for the result, there are four main results we can conclude from the study journal, which is various system is developed. So to further on, multiple manufacturer has come up with their own research and development unit to further develop the semi-active suspension, such as Orleans develop their CES system, which meaning of continuously controlled electronic suspension. For Jaguar and Land Rover, they share the same CVD system, which is continuously variable damping. Second result, widely used semi-active suspension. More automobile manufacturers interested to use the semi-active suspension system in their product and give the consumer to experience the best suspension system that balance between handling, performance and comfortability. Lastly, with semi-active suspension system, we can get better handling and comfort. With the research and development that has been done, the semi-active suspension system proved that it can deliver better handling performance to suit high performance car, also provide better comfort and stability going through rough road surface. So the summary of my review journal is, the title of the journal, Semi-Active Suspension System from Research to Mass Market. The name of the journal, Journal of Low Frequency Noise, Vibration and Active Control. The month and year the journal published is October 2019. There are three methodologies used in this journal, which is semi-active dampers principle, classical control strategies, modern control strategies. And the result obtained from the journal is there are various systems developed, widely used semi-active suspension, and also better handling and comfort. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Amir bin Abdul Halim, and I'm going to present summary of road excitation classification for the semi-active suspension system based on system response. The name of this journal is JVC, or Journal of Vibration and Control, which was published on January 2017. The methodology used are signal pre-processing, feature fusion, feature reduction, and classification with PNN. For the results, is based on the simulation made. First is methodology. Signal sampling and pre-processing. The 6 road types are applied on QOV model, which is quarter of vehicle model with stamping characteristic, and application of skyhook control to validate the proposed classification method. 3 different system responses, which are the sprung mass acceleration, unsprung mass acceleration, and rattle space, are selected as candidate signal for analysis. The pre-processing is implemented in 3 distinct steps, which are low-pass filtering, framing, and windowing. Feature fusion. To improve the resolution within a certain frequency range, wavelet packets decomposition is utilized to decompose system responses. To decompose system response signals into 6 components, a total of 29 features are calculated to form a feature vector. Feature reduction. Minimum redundancy, maximum relevance, or MRMR is utilized to select 4 superior features from the obtained 29 features. Classification with PNN. A probabilistic neural network, or PNN classifier, is applied to determine road classification outputs. A typical PNN contains 4 layers, where the value of the data sets is imported from the input layer into the network. Neurons in the pattern layer are connected with the input layer. For the result based on the simulation, first, the simulation based on nominal number. All 3 system responses can accurately identify all 6 road levels with the accuracy of more than 86%. Compared to the rattle space, both sprung mass and unsprung mass acceleration demonstrate better performance. The lowest classification accuracy of these 2 responses is 94%. For the simulation based on control parameter, the change of classification results for different control parameters and gains is not obvious. For the simulation based on sprung mass, compared to the variation of the control parameter, changes in the sprung mass deteriorate the classifier performance, especially for the sprung mass based classifier. Classification errors predominantly occurred while driving on a highway with gravel and ISO-E. In this case, it can be concluded that the unsprung mass acceleration is more robust to variations in the sprung mass than the sprung mass acceleration. Summary of numerical simulation. Ranking from the best to the worst can be decided as unsprung mass acceleration, sprung mass acceleration, and finally the rattle space. Okay, that's all from me. Thank you.
For the conclusion, as vehicle gets more modern each day, it is not long from we can see that all types of vehicle uses semi-active suspension in the vehicle. Semi-active suspension also evolve from time to time to improve the ride of a vehicle and also make it more attainable in a regular passenger car. Not only the suspension will make the ride smoother, but also reduces the risk of vehicle to make uncontrolled movement when driving this vehicle. So that's all from us. Thank you.